Linear algebra, essential for understanding artificial intelligence algorithms. How can complex problems be solved faster and more accurately? The mathematics that enables this efficiency is linear algebra. Linear algebra began as a geometric effort to handle figures and space more effectively. Today, it serves as a mathematical tool for solving systems of equations with multiple unknowns. It plays a central role across engineering, the natural sciences, the social sciences, and economics, and forms a key foundation for fields such as electrical circuits, communication networks, computer graphics, and game theory. In recent years, it has become an essential tool for understanding and implementing artificial intelligence. Concepts such as matrices, determinants, vectors, and vector spaces can be processed very efficiently by computers. In simple terms, linear algebra is the field of mathematics that reduces complex conditions and solves problems within the consistent rule of linearity. What then is linearity? It is slightly different from the straight line that comes to mind. In mathematics, linearity is defined by two properties, additivity and homogeneity. For example, if the result of adding two values and then computing is the same as computing them separately and then adding the results, it satisfies additivity. If scaling a value by a certain factor produces a result that grows by the same factor, it satisfies homogeneity. Why is this property important? No matter how large or complex a problem is, it can be divided into smaller parts. Each part can be calculated, and the results can be added to obtain the same outcome. It is like completing a large puzzle by assembling each piece rather than solving it all at once. This approach increases the speed of computation and allows large amounts of data to be handled efficiently. It also becomes easier to predict how changes in the input affect the result. When linearity holds, many established methods can be applied directly without revalidation, which is a major advantage. Now consider the relationship with artificial intelligence. Artificial intelligence is a technology that uses computers to imitate human thinking and learning. In other words, it studies how computers can perform tasks such as recognition, judgment, and learning in place of humans. Today, artificial intelligence is used in almost every field, including law, the humanities, business, and entertainment. Artificial intelligence can be divided into two main types. First, rule-based artificial intelligence operates on clear rules such as, if this condition is met, then perform this action. For example, if an email subject contains certain words, it is automatically classified as spam. This method has a simple structure and produces predictable results. However, in complex situations such as autonomous driving or speech recognition, it has the limitation that all possible cases must be defined in advance by humans. In contrast, neural network-based artificial intelligence is modeled after the structure of the human brain. It learns by discovering patterns from large amounts of data. Even in the same spam filter, it does not look at a single word. It analyzes meaning, context, and patterns of word usage, leading to far more precise decisions. The key element is the weight, and linear algebra is used to calculate and adjust these weights. What kinds of linear algebra are needed for artificial intelligence? The most fundamental concepts are matrices and vectors. A matrix is a tool for transforming data, and matrix multiplication and linear transformations play a crucial role in computing weights in neural networks. Data must be converted into a form that a computer can process, and this form is the vector. For example, consider the instruction, move 3 meters to the right, 5 meters forward, and 7 meters upward. When organized by the axes, left to right, front to back, up to down, this can be expressed as a single vector, 3, 5, 7. If a movement of 1, 2, 3 is added, there is no need to calculate each component separately. Simply add them to obtain 4, 7, 10. In this way, linear algebra transforms complex information into a simple structure and enables fast and efficient computation using that structure. Ultimately, the reason artificial intelligence can learn quickly and make accurate decisions lies in this powerful tool, linear algebra.